Hello there, welcome to lesson number 1 in our series on using FluidDesigner for 3D printing to create rings. You can of course download FluidDesigner for free from our website at fluiddesigner.co.uk. Once you've downloaded it, your opening screen should look something like this. And we need to go to, we're doing rings today, so we need to go to Learning Projects, Jewellery Projects, Rings. And we're going to do lesson 01, which is just a simple torus ring. Now I'm just going to switch on the screencast key, so any key presses I make, so if I press A for example on the keyboard, A is to deselect all and select all, so I've highlighted the torus ring. This is what we're going to create. Key presses will be displayed in the panel here. If there are no objects displayed here, you can always click on Group Library, that will reload them. And so in today's lesson we're going to create a simple torus ring, just showing you really the mesh function for torus. So what we want to do is to add a mesh and add a torus mesh. So if we go to add mesh and a torus, that adds a torus mesh. Now at the moment you can see, well you can't see very much, the object is really tiny, it's just 2.5 millimeters by 2.5 millimeters. But if we if we go to view and zoom to selected, you can see that the general shape of this is the same as the finished object at the bottom. It's a torus ring. At the moment the values for X and Y, X is the red direction, the red arrow. So the external diameter of this is 2.5 millimeters, and similarly for Y, the green is the Y, so the external dimension is 2.5 millimeters. So we clearly want to increase that. But if we either press T on the keyboard, T for toolbox will open up this panel here, or if we click on the plus sign at the top there, and you'll see that we've got this drop down panel here, and if I just move that up, it says add torus. And if we look at this, there are some values in here that we can actually change. At the moment it says major segments 48. Well, what are the major segments? Well, if I just reduce these, and I'm really going to reduce them right down, so I've reduced them right down to 3 by holding down the left mouse button and dragging. The major segments are the number of segments going around the object. So we've got 1 segment here, 2, 3. So if we change that to 4, we're getting a square ring. So we've got 4 segments going around, 2, 3, 4, and 5, and 6, etc. So the major segments are the number of segments going around the object. Now the higher this value is, the more segments there'll be, the more rounded the finished object will be. Now the largest value we can set it at is 256. That will give you the smoothest surface finish in that direction, going around the object. If we set it right back low again, so I'll set it right down to 3, and if we zoom in, there's another segments that we can change, and that's the minor segments. And again, I'll set this right down to the bottom. The lowest value you can set is 3. Now the minor segments are the number of segments going around the major segments, so going around this way. So we've got 1 face there, 1 face there, and 1 face on the inside. So there are currently 3 segments going around this object. So if we change that to 4, there will be 4 faces around the object at the moment. 5, 6, 7, 8, okay, 9, 12, etc. So the more minor segments we have, again, the more rounded this shape is going to be, the smoother it's going to be. So if we set this to the highest value that we can go, so that's also the highest value, 256, you can see that now that is looking quite smooth around the object. So if we set this one up to 256, the major segments up to 256 as well, whoops, that's the smoothest that we're going to get in FluidDesigner. Okay, so 256 and 256. We've still, however, only got X and Y dimensions of 2.5. So we want to change these radius values here. Now clearly as we increase these, so the major radius is actually the radius from the center there to the middle, not to the outside, to the middle of the torus. So clearly as we increase that value, our torus is going to get bigger, and as you can see, we've got up to x of 28.5 millimeters now. So the 28.5 is the external value, the external size of this torus. The x and y value here, 28.5, is actually made up of 14 millimeters from the center to the center of the torus, 14 millimeters from the center to the center of the torus on the other side, that's 28 millimeters, plus we've got the thickness of this torus itself. So we've got 0.25 millimeter radius on this side, that's called the minor radius, that's the radius thickness of the radius of the actual torus itself, and 0.25 on the other side. Add that all together, you get 28.5. Make more sense when I change this up to a value of 1 millimeter. So if I click in here and type 1 millimeter, okay, so the minor radius is the radius from the center of the torus to the outside of the shell, so that's 1 millimeter. 14 millimeters is the major radius, so in other words, from the center here to the outside of the shell is 15 millimeters. If you double that, you get 30 millimeters in total. So at the moment, this torus shape is actually, it's got a 1 millimeter radius, so it's got a thickness of 2 millimeters. A thickness of 2 millimeters. Now, with any ring, you've got to know what the internal diameter is going to be for yourself. So if we assume that the internal diameter of your ring has got to be 25 millimeters, we want some way of measuring that. Well, first of all, what I'm going to do is delete this original one. Okay, just to get it out of the way so it doesn't interfere. And then if I go to view and top view and then scroll into this object with the center mouse button, notice this panel's disappeared now. Once we start clicking on other objects, we're no longer going to be able to change any values of this torus, so you do need to be a bit careful about that. Eventually those, as soon as you start clicking elsewhere, these values that we were changing for the number of segments and the radiuses, they will disappear eventually, so you will lose them. So if I view from the top, and at the moment I've just noticed this is also in perspective mode here. It's usually a good idea to switch from perspective mode to ortho mode. Oops, that's changed it a little bit. Okay, I'm just scrolling out with the center mouse button. So we're looking at the moment in top and ortho view. And what I'm going to do is along the toolbar here there is a interactive ruler, so I can measure the internal diameter of this using the interactive ruler. So it's 25.88 millimeters at the moment. So if we, and I'm just going to press the escape key to cancel that. So that's the interactive ruler, it's on the toolbar there, and I'm just scrolling the center mouse button to scroll across the toolbar. If we want an exact inner diameter, if we know what size you need for the ring that you're going to print, one way of doing it is the interactive ruler. A more accurate way of doing it is if we add a mesh, and if we add a cylinder mesh. Now at the moment that cylinder mesh is the dimensions of it, the external diameter of it is 2 millimeters by 2 millimeters. So if we change this to say 25 mm, 25 millimeters for X and 25 millimeters for Y, what we've got there is an object that we can scale down our ring to. So if we scale our ring down so that it just fits around that cylinder exactly, we will know our internal diameter of our ring will be 25 millimeters. So if I just go to view and top again and just scroll in, So we're just using this cylinder as a measuring object. So if we now click on our torus ring, we can see at the moment we've got the torus highlighted. These are the external dimensions. We want to set an internal diameter of 25 millimeters. Now it's usually a good idea at this point to point the mouse away from the object, because what I'm going to do is I'm going to press the S key on the keyboard. S key on the keyboard is for scale. And with the torus selected now, if I move the mouse, you can see I can resize, I can scale the torus. And so what I want to do is to move it until it just fits around the outside of that cylinder, that 25 millimeter diameter cylinder. So once I'm happy with that, I can click the left mouse button. So I've scaled down the torus so that it fits just around a 25 millimeter cylinder. Now, one of the things that's very important to do in FluidDesigner, if you scale an object, if you resize it, these values here, the vector values for X, Y, and Z will change. These default values should be 1. So we need, whenever we scale an object in FluidDesigner, we need to reset the scale. And we do that by holding down the Control key and pressing A and applying the scale. This is with the torus still selected. So whenever you resize, and if I just move this window across a little bit, I'll just zoom back, you'll see that the scale is now ticked. We need to do that if we're 3D printing. So we've resized the ring, and we've now reset the scale back to a value of 1, the default value. So I'll just move that toolbox panel out of the way. Now all I need to do is I need to delete this cylinder. That's not an object that we're going to print, so it's X on the keyboard and delete it. So here's our torus now. What we need to do is save this. So if we go to File and Save As, and go up through the menu system, we don't want to save over the learning project, over the original file. We're going to save it in the My Projects, Jewellery Projects, Rings folder. So it's My Projects, Jewellery Projects, Rings, and we're going to save it as Lesson 01 as a simple torus ring, and we save that as a Blender file. So there's our simple torus ring that we've modified in FluidDesigner. Now we must always export this as a printable file format and check it in a piece of software called NetFab Basic. So what I'm going to do now is to go to File and Export it, and we like to use the Wavefront OBJ format. It's not the only printable file format, but it's the one that we tend to use. And I'm just going to save this to the desktop, so it's Lesson 01 Simple Torus. We save it this time as an object file, not as a Blender file. So I export that to the desktop. And then I need to start the application NetFab Basic. And NetFab Basic is a tool for analyzing meshes, making sure that they are printable. So if we go to Project and Open, and go to the desktop, if we open 01, the Simple Torus, that's our ring that we've created. It's got an internal diameter of 25 millimeters, which we've just set, and it's got a thickness of 4 millimeters. So what we need to do in NetFab Basic is go to Extras and Repair the Part. And if I just move the window across, because we can't see everything at the moment, if I just click on Update, there aren't any issues to repair here. There are no border edge problems, no orientation, no holes. There's only one shell. A lot of edges and a lot of triangles, 131,000 triangles, but we would always recommend you run automatic repair and execute, irrespective of whether there are any issues here. Click Update again, there's still no issues, but we'd always say apply the repair and remove the old part. NetFab will have done something. It will have triangulated this object, which you'll see more clearly in other lessons that you do. But all we need to do now is to go to Part, export the part as a wavefront object, export it to the desktop. So the file 01 Simple Torus repaired, that's the printable file. Okay, so that's it. That's the end of today's lesson, creating a simple torus ring in FluidDesigner for 3D printing. Thank you.